Hello, everyone, and thank you for joining today's webinar. My name is Reese, and I'll be your moderator today. We're going to kick off today's session in a couple of minutes. We're just waiting so everyone has a chance to join. In the meanwhile, though, let us know where you're joining from using the chat or the comments, depending on what platform you're watching on. And yeah, if you have any questions for our hosts today, then let us know in the chat as well. I'll be saving them for the Q&A. One bit of housekeeping before we kick off: the session is being recorded, and the recording will be emailed to everyone that's registered for the event. So if you haven't done that already, then I'll be posting a link so you can get registered for the event and get everything sent over to you via email. As mentioned, we are going to have a Q&A, so if you have any questions at any point throughout the session, please let us know in the comments and the chat, and I will save your questions for the Q&A. Brilliant. I'll be back to repeat these messages shortly for any new joiners, but until then, enjoy the background music and make sure you get registered for the event. Hello, everyone, and thank you for joining today's webinar. My name is Reese, and I'll be your moderator today. We're going to kick off today's session in, about 15 seconds or so. We've just been waiting so everyone has had a chance to join. Let us know where you're joining from using the chat or the comments, depending on what platform you're watching on. And yeah, if you have any questions at all throughout today's session, then please let us know in the comments, and I will save them for the Q&A. This session is being recorded, and the recording will be sent to anyone that's registered for the event. If you haven't done that already, head over to our LinkedIn, or I've also sent a link in the chat as well so you can get registered so that we can send you all the goodies. Brilliant. I think that's everything from me. So now I'll hand you over to your host for today's session, Richie. Richie, please take it away.
Welcome, everyone. This is Richie. Now, we talk a lot about data-driven decision-making at DataCamp. And the idea of using data to back up your decisions is incredibly powerful and, in fact, fundamental to good business. Unfortunately, it's one of those things that's easier said than done. And to do it consistently across your company requires thousands of changes to tools and process and culture. So that means that today we're going to sweat some of the details in how you can change your organization to get better at data-driven decision-making. And our guest is Dhiraj Rajaram. He's the founder, chairman, and CEO at Mu Sigma. So Dhiraj founded Mu Sigma way back in 2004 to help companies make better decisions with data. So he's been working on today's topic for a long time. And in addition to his data leadership, he's been a very successful entrepreneur. So he was twice ranked in Fortune magazine's 40 under 40 list of influential leaders. And he was awarded the Ernst & Young Entrepreneur of the Year India Award back in 2012. So thank you for joining us, Dhiraj.
Thanks for having me, Richie.
Wonderful. I'd like to dive straight into the questions. So to begin with, just can you give me an example of when you think data-driven decision-making is a good idea?
I think for most decisions that we make today, we are living in a world where we moved from an industrial era to an information era. This data being captured for pretty much everything that you can think of. Not using that to make a decision would be a crime. Having said that, how much do you how much do you how much should you invest into you know uh, thinking of making a decision with data versus your intuition. Now that's an art as much as it's a science. um, I still believe that there is value for intuition in what we do. There is value to, especially when you're thinking about asking the right questions and how you interrogate for what the truth is. So it's very, very important that you don't let go of your intuition. But having said that, um, looking at data is becomes more and more important. And there's three kinds of data: the data that you have easy access to, um, and you can look at it very quickly. There's data that you don't have such easy access to. Maybe it's not in your organization, you need to get it from outside. And there's data that you may need to create. And the value of the insight that you have, is very different the more data you use, and the more differentiated your data is. So I sincerely believe that the big D is not for data, but it's actually for decisions. And how you get to those decisions become very, very important. And data is a big input in that journey, but not the only input.
I think it's an incredibly important point, the idea that data isn't the be all and end all, and that you do need some intuition there as well. So I'd love to get into that in a bit more detail later on. But just to begin with, can you give us a success story? Have you seen any examples of organizations where they've developed that habit of using data for making decisions and they've seen some sort of benefit?
We work with more than 140 Fortune 500 customers. These include the largest retailers, software companies, publicly traded insurance companies, pharma and healthcare ecosystems. And there's a wide variety of decisions that get better made because they are made around data. Now, I would say that the kind of decisions that you would make could range from a functional perspective, sales and marketing area, to supply chain, to product, understanding risk, um, and a whole host of other things, which could be there's a long tail of stuff around which data can be used to make decisions. But I want to make this a little real for you, so we will actually take an example and show you an example of you know of a retailer, looking at a problem space, and understanding how better decisions can be made. One of the some Before I show the video to you guys, uh, I want to give you the backstory. The backstory is that this is a home improvement retailer, looking to better engage with a certain segment of customers. They call the pros, and they want to better engage with them, and they are looking at seeing how they can change that engagement model. Some of the themes associated with this problem will is that the initial problem that was stated was not the final problem that got solved. There is a journey of a problem statement as it becomes problem definition. And that's something which happens all the time in data driven decision making, so one should be very, very comfortable with that. The second thing is, your world is not one or two big problems, but many, many small problems that are interacting with each other. That's how an organization's complexity manifests. So understanding how these interactions are happening become very, very important. Just to give you a perspective on it, if you have two elements like hydrogen and oxygen, they could interact to give life-giving water, or they could interact in other ways, and it could be poisonous and make it hydrogen peroxide. So the quality of interaction of the entities really, really matter. So understanding problem solving as interactions, appreciating complexity becomes very, very important. And you'll see in this example the use of knowledge graphs, and graph theory being used. And the third thing you will see is the use of computer vision to really capture data that you cannot that is not actually entered in your software systems or anything like that, but these are real time data that's being captured in a store, and using that the analysis and the insights become so much better. So in this example, you'll see new kinds of data being created. And last but not the least, the use of Raspberry Pis and Internet of Things, where your edge computing is being practiced. So these are all features that you will see in this video coming up. So I'd love you to play the video, and then I can show you the kitchen behind the scenes as to what do we do to make the food the kind of food that you will see now. So this is the food, and after that we'll show you the kitchen behind the scenes.
The retail store's professional customers are largely remodelers, installers, and contractors for whom the store provides a dedicated special services team. This team helps the retail store with multiple business aspects, primarily focusing on best-in-class service. This includes in-store experience, fast in, fast out, comprehensive assortment, and pricing strategies. One of the key initiatives as part of streamlining operations and serving the customers better is special desk transformation. The current special desk design is a bottleneck for a professional customer checkout experience and leads to a longer wait time. As part of the initiative, the special desks have been replaced by special pods to facilitate speedy checkout and enhance customer service. These special pods not only facilitate wait time and checkout time reduction, but also lead to better interaction with customers. However, what is the challenge? To analyze the effectiveness of the special pods, the team had to manually capture wait times and checkout times due to the lack of data availability and infrastructure. To overcome the challenges from manual counting, Mu Sigma developed an innovative solution combining cutting-edge technology with the new deep learning algorithms in a low-cost setup. The solution has enabled us to process similar information efficiently and at scale. We captured videos for the special desks and special pods from different angles for 3 test stores to capture customer point of sale metrics. A deep neural network model called Reinspect was used to detect humans from the video. This algorithm uses a recurrent LSTM layer for sequence generation. The model is trained to provide high accuracy for human detection with heavily overlapping instances. Since we only needed to detect the people who were making a purchase, we restricted our attention to the area of interest, namely the checkout counter, highlighted here in red. Additionally, the green areas represent a channel where people walk past the counter. After a human was detected, we leveraged the multiple hypothesis tracking algorithm to assign a unique identification number to an individual, which was then maintained when he or she moves in the designated area of interest. This enabled us to now measure the wait time and checkout time of each professional customer without any manual intervention. Once this data was algorithmically extracted, it was used to understand variation in traffic and POS metrics over multiple days to validate the migration from desks to pods and to identify time slots that require further engagement from the retail store. As part of this solution with the focus on scalability, we were able to successfully deploy an in-house IoT device prototype in the Innovation and Development Lab of Mu Sigma, in a specific city store to remotely record and store data without any manual intervention from our office at Bangalore, where the results were processed and validated. The results of our analysis stated that the wait time and checkout time decreased by at least 11% and 12% respectively, which resulted in a decrease of at least 2 minutes in the net interaction time, and a significant improvement was observed in terms of the ease of the checkout process of the professional customers. Building on the existing infrastructure, we can answer adjacent business questions in addition to analyzing wait times and checkout times. One such question could be maximizing impulse purchases, where we could analyze customer buying behavior to strategically plan the assortment at the checkout counter. Another avenue of interest might be addressing a staff optimization problem, where we can analyze peak hours and customer traffic to get insights that can help plan staffing better. There are numerous such instances where we can leverage the existing infrastructure to answer pertinent business questions.
That was a really nice video, because I can imagine if you didn't use data there, then you're going to have all these store designers just arguing endlessly about whether desks or pods are better for customer service, and getting that data was the only way to really come to a conclusion about what you should do as a business to optimize those sort of customer wait times. Thanks. Really nice example there.
Yeah.
I'd like to talk a little bit about the.
I want to make a point here. It's data-driven decision, but it's not. Data is not the end all. I sincerely believe that the journey is from data to dialogue and dialogue to decisions. Um, the presence of data and analytics and insights help the stakeholders, have good conversations, and that those good conversations eventually result in good insights. See, typically when an idea is happens in an organization, that there's a journey of that idea, there's a journey of that concept. It initially is an idea, it's content, then it goes on to become conversations between people. Then eventually, based on those conversations and the analytics around that, insights around that, all of those things, some decisions get made, and eventually it goes into the compute environment. It goes into the company's software and databases and all the good stuff. Once that happens, that becomes part and parcel of how the company runs, and it gets consumed by business at that point of time. So that's the journey of that concept. Now, but to do all of this, you need, if you're going to make good food, you got to have a nice kitchen behind the scenes, right? So what I want to actually show you for this specific, for examples like these, what would be an industrial kitchen that you would need to operate. So I want to maybe share my screen to make that happen. If you can help me bring that up and let me know when my screen is active. Yeah, I can see that. So this is something that we've developed over the last 18, 19 years of working. We realized very, very early on that making the kinds of food that we want to make without a kitchen was becoming more and more cumbersome. We needed structure in place. Why is structure important? Well, structure is important because if you want to do more with less people, you will need structure. If you want to do more faster, you will need structure. If you want to do more in a sustainable manner, you will need structure. And last but not the least, when you have a new problem that hits you that you didn't anticipate, if you want to have enough slack and so that you have the bandwidth to solve for that problem, you need structure. So structure becomes really, really, really important. Now, this is an ecosystem that the business exploration ecosystem that we've created that allows for structure to happen. It consists of two parts. One is navigating complexity, understanding how things are connected to each other and how are they interacting with each other. And the second one is achieving the transformation that you want to make. It's not, making the decision, then using that decision to come up with new technologies, new ways of the business operating, and eventually resulting in better impact for that business. So I want to start by looking at this. We fondly call this our inquiry engine because questions are more important than answers. That's what we feel. And in a world where questions are more important than answers, what's the science of asking a good question? And you will see very, very clearly with technology evolving that, technology is aiding us and making it easier and easier to come up with an answer. But asking a good question is still very difficult. So from that perspective, we developed two ontologies for problem solving. One is bottom-up thinking for granularity, and the other is top-down thinking for outcome-based, decision making. Now, let me start by looking at the bottom up ontology here. We call it the problem DNA. And here, I just take one of those problem DNAs. And here is the journey of the problem. There's a current state of the problem, there's a future state, there is a problem solver who wants to solve this problem, and there is a solution consumer, the business side, who wants to have a solution. But initially, the problem is never designed, defined very nicely. It's very muddy and fuzzy. So you got to do some research, but you have to have a very systematic way of doing that research so that you know everything surrounding you. You're entering this jungle. You want to make sure that you know the kind of jungle you're entering. You want to anticipate some problems. You want to anticipate some wild animals coming in, so that you're a little safer. Once that research is done, you have a better chance of understanding what the gap between the current state and the future state is. Now you're ready to have a dialogue. You want to not solve the problem all by yourself. You want to be around other people, around your community as you're solving that problem. Typically, the business and the practitioner typically have a conversation like this, and they say, hey, what are the factors? What are the sub-factors? What are the attributes and metrics? What are the questions? For these questions, what are the various data sources that I could have? Once this is set up in a very clean manner like this, it allows for you to create a hypothesis matrix where the rows are all the questions and the columns are all the data sources. And the interaction between the rows and columns is the interactions between questions and answers. All insights happen at the interaction between questions and answers. So this sets it up very, very nicely for a granular problem definition, right? So once this is done, I go back and say, okay, this allows me to get into the details, be atomic. But if I want to have I want to see the forest from the trees. I want to be far more outcome oriented. I have a senior leader in the company for whom I have to explain what I'm doing. That we have a different ontology that we've set up where we can actually say, hey, you know what? Wave one, I'm going to do a certain set of things. Wave two, I'm going to do certain other things. And wave three, I'm going to progress towards a better outcome. But in each wave, what are the financial and business outcomes? What metrics am I trying to change and how much am I trying to change it by? What is the business willing to commit that they will change? And where are the analytical insights going to come from? Now, it's very important that you are able to learn about insights from multiple industries. So we've allowed for the organization to have that perspective. So if you're a retailer, supply chain, store operations, merchandising, you could go to pharma and look at commercial sales, marketing, medical affairs, R&D. If you're in oil and gas, looking at material management. So all of these allow you to learn from multiple industries because there is something somebody is always doing better than you, and there is something you can teach somebody. So that perspective is very, very important. And then the top-down thinking meets the bottom-up thinking here because everything below here comes from the problem DNA that I just explained. So the bottom-up and the top-down ontologies are established, and just with these ontologies and nothing else, and using graph theory, we've been able to develop these kind of graphs, which tell you the story of how the complexity in the organization is, how you understand. It's not just about one problem, but it's about many problems that are interacting with each other. It allows you to see the problem space not as stars, but as constellations, because it is in that constellation where you can have a holistic perspective and you can make a better decision. Right. So this, so this perspective of seeing the problem space as a network, all work in the future is going to be network, guys. Your algorithm is a network. Your problem space is not one or two big problems, but many, many small problems, but are interacting with each other. So seeing this as a network becomes very important. And last but not the least, you want to be able to measure what you're doing in terms of a decision supply chain. That journey of that decision, all the way from business understanding to practice of analytics to business impact. Who is doing what? What's the practitioner doing? What's the business doing? And how are all these people collaborating? So this perspective, this kind of industrial kitchen is required. So as if you're a big organization and you're interested in solving, problems, and you want to move from anecdotal project to project analytics to programmatic decision sciences, um, you know, um, then you better have an industrial kitchen in place. Otherwise, you're not going to be able to, scale, which is going to be very very important, because there's no silver bullet around a decision. You gotta see that animal from multiple angles, and then you kind of realize what kind of animal it is, and then that's the better way to solve for that problem.
That was absolutely fascinating. I have many questions about that. I'm going to ignore my previous questions. So you mentioned that there are sort of two structured approaches you can take. You can either take the bottom-up approach, which is starting with your data and then trying to work towards an outcome, or the top-down approach, where you start with the outcome and then sort of work backwards
I
to
would
how you
say
might.
either or. I would say and. It's better to do both.
Okay, so I'm curious as to when you would decide on one strategy over the other.
Well, you know, uh, I think both serve very different purposes, right? The bottom-up approach allows you to make sure that you're collectively exhaustive. The top-down approach allows you to move towards being mutually exclusive. Because you don't want to boil the ocean when you're having a conversation with a senior leader. They don't have that much time. And the world of data is such that, unfortunately for all of us, the rate of increase of noise is far higher than the rate of increase of data, or signals. So the noise to signal ratio is such that you already have too much noise. So your ability to synthesize what you're saying into what is very useful is going to become very, very important. So that allows us to look at the world and say that, hey, here is the bottom up perspective for solving the problem, but how I am going to, my approach towards decisioning is going to be guided by my top down perspective. So both of them serve very very different purposes. Ideally, we'd like to do both together. So the program is defined by the top down perspective, but all these individual projects are defined by the bottom up perspective. So those two things achieve very different things.
Okay, so really it depends on what sort of level you're looking at. It's like, are you trying to solve one of those individual problems or a kind of broader, I think you used the term constellation of problems before.
Yeah.
Okay,
Yeah.
nice.
Think about, it's a good question. That's why I want to, add a little bit more. Look, your world of problem solving has three parts in it. There's inputs, various things that go on to the problem solving. It could be data, it could be the algorithms, it could be the technology, it could be people, it could be the biases. All of these are inputs into that. Now, they all think of them in terms of all the various raw material you need to make that dish, right? And then there's the output. What are you making? Is it descriptive analytics, dashboards and reports? Is it inquisitive? Is it predictive? Is it prescriptive? Are you building an AI engine? All of those things are outputs, right? So you have many inputs interacting to create an output. So if you're in the food analogy that we used, the output could be a pasta dish, it could be a salad, it could be lasagna, whatever you want to do, right? But eventually you want an outcome, right? An outcome is very different from an output. What is it going to do for me? Is it going to reduce my inventory turnover? Is it going to reduce churn? Is it going to increase my profitability? What am I doing there? What's the outcome? So the outcome is like, what am I? Okay, I'm making all this food, but who am I making it for, and what's the event, and what am I trying to achieve? Is it like a birthday party, or is it a romantic dinner? So what are you doing that? What's the outcome for? So that perspective is going to be very very important to move from inputs to outputs to outcomes. Thinking about it in that perspective is very very important, and that allows you to kind of guide yourself.
I like you mentioned like birthday parties or a romantic dinner. Like, this is something you can use in your day-to-day life as well as in your organization. But just sticking to the sort of business context, I'm curious as to how you go about making sure that people can adopt this habit of actually building data into this process and having this structured thinking around decision making. Because often, just building up and adopting these sort of habits is going to be key to the success. So, what do you do to encourage that at Mu Sigma?
Look, I think, we at Mu Sigma understood that the basis, of everything that we do comes from three perspectives that we have, but they're all connected to each other. All of these perspectives come from a world of creating abundance. Uh, you want, problem solving not to be driven by fear. You want it to be, you want to, but at the same time, the fear is a very natural instinct because you don't want to get things wrong. But a combination of fear and fun makes it adventure. So how do you make that problem solving process adventure, right? And for that to happen, you have to operate, um, you know, to create a world of abundance. And to create that world of abundance, the first thing you need to do is look at the world as learning over knowing, because there's so much abundance in learning. There may be scarcity in what you know, but there's abundance in learning. So that approach of learning over knowing becomes very, very important. Um, okay, so that's your why. Then what's the what, right? And from that perspective, we say that you better not be governed by what the experts are saying alone, and not be constrained by that. But you yourself may not be the expert on all topics, so there may be things that you will have to experiment on. So experimentation over experts, right? So, and the last thing is, don't keep secrets in this world. The new IP, I feel, is interaction property and not intellectual property. So the more secrets you keep, the less interactions you're having, and the chances of having a serendipitous insight goes lesser and lesser and lesser. Now, what you will see is that the learning over knowing perspective creates a world of humility. The experimentation over experts creates the opposite of that. It creates a world of irreverence. So you have to harmonize humility and irreverence. And how do you do that? How do you have the wisdom to harmonize that? And that happens through the multiple interactions we are having. By talking to you, I'm going to learn a little bit from you. I'm going to tell you, I'm going to be able to share some things with you that you may find useful. And that's where all the value gets created. And all of these things that we are doing is enabling the people in the organization to have better interactions, better dialoguing process, and through which they'll be able to get to a decision even better.
I do like that idea that humility and irreverence are really important sort of characteristics of a good sort of data-driven organization. Um, I think for a lot of organizations, they're just getting started with this. So, what's step one when your CEO says, "Okay, we need to get better at working with data"? How do we do that? Where do you begin?
Well, I think, most large organizations have already, been doing something in this area. So so this may not apply to many of the large organizations. But having said that, wherever you are, understanding the state of the union is going to be very, very important. Understanding the lay of the land, what is the investments you made, what's the quality of your data, all of that is going to be very, very important. But it is only you should while you should look at everything, every one of those reasons could be a reason to stall. And how you don't stall is basically leadership, right? Because clean data, good data, connected data is a utopian concept. It doesn't exist anywhere, right? So how do you move forward despite that? So that's very, very important. And so that's that perspective. Once you had, then the second thing I would say is educating senior leadership about what the art of the possible is, and starting the journey of them creating expectations for their teams, saying that okay, these are all things that we should achieve in data driven decision making, in the use of AI, in the use of predictive modeling, in the use of all of these next generation technologies that are coming up. um, Last but not the least, as much as you're looking at making food, also build your kitchen. Because if you're only focused on making food, it's going to give you an immediate satisfaction, but it's not going to be sustainable after some time, right? So how do you harmonize between solving specific problems and creating a better art of problem solving? That's going to be very, very important. Some of the more advanced nuances, especially in a world of AI and generative AI and all of these things that are coming up right now, is an appreciation for complexity in your organization. Understanding how various entities are interacting, how you can represent those interactions, and then use those representations to acknowledge the complexity and address the complexity and nudge your problem solvers to think as constellations and not as stars.
Nice. So you mentioned that you need to understand a sort of state of the union, like how good you are at working with data at the moment. So, how do you go about measuring that sort of level of data maturity, and how do you know when you've become successful at using data?
Well, actually, the answer is you don't. You can just make progress. It's an ocean out there. So the best way to think about it is not in terms of destinations, but in terms of journeys and progress, and saying, okay, am I doing better today than yesterday? So that's a better perspective I would have, rather than saying that I'd like to get to a certain destination, because these things are changing so much. The technologies are changing, the math is changing, the quality of data is changing, the business concepts are changing. We are living in a world of uncertainty, and how one responds to that uncertainty is going to be very, very important. And therefore, not having very definitive perspectives as to this is the where I want to be, is also, it's a healthy practice, I would say. um, so that's how I would go about it. But there are many organizations that can help. We are one of them, but there are many organizations like us who are helping large companies think about this and building a horizontal capability in decision sciences. And I think the future of decision sciences is by being a horizontal, and hopefully it will touch every part of your organization. Because if you're a company, your customer is not going to look at the problem as a marketing problem or a supply chain problem. He's going to be looking at the problem as a problem for him, and he's going to point your company, saying that, look, you need to solve this problem for me.
So you've mentioned the term decision sciences a few times. I think a lot of people here will have heard of data science, but decision science may be a new term for them. So can you just explain what's the difference between data science and decision science?
I got to take a step back for that. So first, let's start with um, data engineering, right? And I'm going to try to put it in kind of layman terms because it helps me think about it. So data engineering is like making sure you know where all your data is, are they healthy, and so on and so forth. That's like your refrigerator, you know that's kind of where you put your food, and you know where your vegetables are, where your milk is, where your eggs are, where the freezer is, what's the freezer used for, all the good stuff. That's the refrigerator, and you're getting better and better refrigerators right now. So that's good. Moving your data from one refrigerator to another refrigerator doesn't make you have better food, right? So that's the first part of it. Then the interaction of all of that with math, with technology, understanding all of that helps you get to this perspective of data science. Now, data science could be, descriptive. And now there's a big difference between analytics and data science. Also, analytics is just coming up with that data and and like coming up with metrics and all of the good stuff. But data science is a little bit beyond that, where you also come up with an insight. So this perspective allows you to say that, okay, what are the various kinds of data science? It could, it could be descriptive, dashboards and reports telling me what happened; inquisitive, why something happened; predictive, what will happen; and prescriptive. So what do I do about it, and so on and so forth, and with recommendations and all of those things. That's data science. Now, decision science is the use of those insights to make actionable decisions. How am I going to consume it? How am I going to get my business people involved in it? How am I going to create feedback loops? How am I going to create learning ecosystems in place? So, all of that which makes money, because without making money, it's going to become very, very hard to be sustainable. So you can be very passionate about what you do, but eventually you got to be useful. And so that perspective of taking all of the your purpose and passion to make profits is going to become where decision science happens.
I do like that analogy is data is food. So yeah, you've got a data analyst just like counting like all the different bits of things in your fridge, and your decision scientist going, well, yeah, okay, let's use those and we'll make an omelette or something. Brilliant. Okay, so I think one thing that's often tricky with this idea of like making better use of data is that the needs of different different teams around data are very different. So, do you have any advice on like how you make sure that every team has their needs adequately addressed?
Uh, you know, um, the reality is that our organizations that we live in today um, have been built uh, at an earlier time, um, and um, and and at a time where execution was a lot more, was a differentiating factor, right? And today we are living in a world where exploration is the differentiating factor, right? And the from that perspective, what's happened is that most organizations are built as silos. There's a CEO. Under him there are 5 or 6 or 7 people. Under them there are again seven people, and so on and so forth. And that's how it's a very hierarchical system that's built as a tree, which is very unordered. It's a very ordered system. You know exactly what your an organizational tree is very ordered, but the problem space is not so ordered, right? The problem space is a spaghetti. Things, everybody is talking to everybody, and so on and so forth. So you have an ordered tree which is trying to solve a very, very unordered, disordered, chaotic problem space, right? So that's where the problem actually starts, right? So the first thing we find in many of these organizations is that they're all operating in the silos. So there's a lack of transparency of all of the content, right? Things are sitting in one end, other people are not able to see it, and so on and so forth. There's a lack of persistence in the conversations. And eventually, there is a lack of cumulativeness of all the work that you do. So you'll end up doing anecdotal project to project analytics and not programmatic decision sciences. So moving from project to project analytics and programmatic decision sciences means that you will need the ability to solve for the lack of transparency of the content. You will need an ability to solve for the lack of persistence in the conversation. So you need to have a neat way to capture that persistence. And last but not the least, you need an industrial kitchen in place so that eventually all of this work becomes cumulative and you're not doing the same work again and again, and so on and so forth. So we are in the early days of decision sciences, guys. And all of the things that we did with data was just getting us to this spot of this early days of decision sciences. So that's how I would look at it.
That's fascinating because it sort of feels like data science as a field is kind of is starting to mature, but you're saying decision science is a lot newer and it's still got a long way to go. That's interesting. So, I think related to this idea, there's this concept of sort of self-service analytics where anyone in your organization can ask questions about data and answer it themselves. And this seems like the holy grail for analytics rather than just having to send everything to a data team. So do you have any advice on how you can make people self-sufficient in terms of using data?
I think, look, today's technologies cater to a very federated approach. The more, the better it is if your decision happens at the edge, because then you can operate faster as a company. We are living in a world which has moved from bigger is better to faster is better. We are living in a world which is moved from competing on economies of scale to competing on economies of speed. We are living in a world which used to make products and services but wants to make experiences right now. The science of experience and the science of interactions are one and the same. So your ability to look at problem solving as interactions become very, very, very important, right? So from that perspective, if you can if you can operate with this perspective that look, whatever I do is good, but how I collaborate with my teammates is going to be that much more important. So that's going to make that journey move faster and faster towards decision sciences, right? So having this perspective of having a centralized group which focuses on building a kitchen, but having a federated group which does a lot of self-service, which can or semi-self-service, is going to become very, very important. And I would be very, very cautious with building tools that don't change often enough, because the world outside is changing really, really fast, right? So if you built a tool and you built a self-service tool and it's working very wonderfully for you now, but doesn't mean that it'll work 6 months from now. So I would keep, I would do something called optimal completion. Optimal completion is you completed 80%, but leave 20% flexible, which allows you to kind of, always customize your end. So that's going to be very, very important. I think in the future, everybody at some level will be a decision scientist, and will be playing with data. I mean, like, my grandfather used to be a typist at Times of India. It's a newspaper, right? Today, there is no role called typist. All of us type, right? And that's what the future will be. All of us will have this thing called data science and decision science in us. We won't be so special by being a data scientist anymore. I mean, that's my perspective. That's the future I see.
That's absolutely fascinating, and I agree with you that a lot of these roles are changing, and different technology sort of means that your actual job content can be very different. So you mentioned that speed is incredibly important now, maybe like what the most important factor driving business. So when I think of working with data, it's to make decisions. It's about thinking carefully and there's a sort of pause for thought. So it's about slowing things down. So how do you reconcile that? How do you make sure that you can use data to make decisions without slowing down?
Actually, there are certain parts of the problem solving that requires slowing down. And I believe that if you can choose those parts very carefully and slow down in those parts, eventually you'll be faster in the longer approach. So there's a very nice book by Kahneman and Tversky written called Thinking Fast and Thinking Slow, which kind of gives you this perspective of system one and system two of your brain and so on and so forth. But I would encourage you to look at that book. But my perspective is, the design phase of the problem solving requires you to slow it down. Then the second part of it is that, before you start playing with data, you need to have a better structure and hypothesis established, because once data comes in, it will lead you. So after that, you start getting led constantly. So that's very, very important that you kind of practice, putting a structure in place and designing, having a good design in place. Design thinking is going to be a very big part, of decision science. So the components of decision science, I feel, are math for sure, understanding of business, use of technology, but also behavioral science and design thinking, and a whole host of other things which I don't even know about as much now, but will become important. Taking the food analogy, little, older cultures will always have more and more complex food. If you notice, I say, and that's a very perspective of the fact that just by having more time allows that food to mature and become more and more interesting. Similar to that, I think as we are going from data engineering to it becoming data science to it becoming decision science, right? More complexity is coming into that solution, into the problem solving space.
That's excellent stuff. So we've got about 10 minutes left. So before we wrap up, I would like to talk a bit about skills. And can you tell me what sort of data skills do you think everyone in your organization needs to have, like even if they don't have data in their job title?
I think it's very hard for me to answer that in the next 5 minutes or 10 minutes. But what we can do for people here is if they would, maybe we have a section of our website which is called Mu Sigma as a university. In a world where many universities have become a business, we are a business that kind of runs as a university. 14,500 people have gone through Mu Sigma while they are studying. So what we can do is put a curriculum out there and share it with DataCamp, and that kind of gives you kind of a guidance towards what kind of skills are happening right now and how it's going to change and so on and so forth. So we're more than happy to do that for you guys.
Wonderful. Thank you. And I suppose related to that, are there any skills that you think are particularly important for learning how to make better decisions with data?
I think this perspective of understanding cognitive biases is going to become very, very important. The second thing that's going to become more and more important is this area of complexity science. In other words, the science of interactions. Understanding the difference between what is simple versus what is complicated and what is complex, and not getting simplistic becomes very, very important in that journey. Sometimes you could say a few cute words in a meeting and get away with it and look smart, but that's a very simplistic approach to life. Long term, you won't be able to create value that way. So understanding complexity science is going to be very important, and all these other aspects.
Absolutely. I completely agree that the idea of understanding biases is incredibly important to making good decisions. All right. So, yeah, before we go to audience questions, I guess, do you have any final advice for people wanting to get better at data-driven decision making within their organization?
I think just be a learner, and don't expect any teachers. We are living in a world where all of us are students together. So learn from wherever possible. And the second thing is, you know, we we are moved into a world of where exploration, has become very, very important, and creating optionality for your organizations is extremely important. Now, if you're in that kind of world, you have to be comfortable, in taking risks and having, a clarity, of the problem space becomes very, very important. So our perspective has been that in the past it was all about reducing variation, reducing sigma, right? It was, you want to have a certain amount of certain average mu, and you want to reduce the sigma. That was the world of the past. If you look at a factory model, if you're making iPhones, you want to make sure they're at a certain quality, and that was the world before. But a world of exploration, you may want to increase sigma, because you may want to have more options and then choose from those options. If you have 5 options to choose from, you're better off than just one, 2 or 3 options. So I think that our as decision scientists, your perspective should be to seek sigma and sigmax yourself. So that's how I would look at it. That's a very nerdy way to end this, but yeah, but that's
No, I like that. Yeah, if you're going to make decisions, you want to have a few options to choose between. That's brilliant. All right. So thank you very much for that. We're going to go to audience questions in a moment. Before we get to that, I want to say we've got a load of exciting webinars coming up. So tomorrow we've got a code along session on data storytelling. So you're going to work through a problem related to environmentally friendly businesses. So no coding experience required for that. And then next week on Tuesday, we've got more data storytelling. So there's a session on effective data storytelling for financial services. And then you've got me talking about ChatGPT Enterprise on Wednesday, and me again on Thursday, where we're going to do a code along on working with the OpenAI API, playing about with GPT and Whisper. So you can mess about with some audio files. And then on Friday next week, we've got another code along. This is one in spreadsheets. You can do some exploratory data analysis. So lots of sessions for you to join. Go to datacamp.com/webinars to sign up. All right. With that, we've got a few minutes left. Let's go to audience questions. And the first question is from Ferras. So Ferras asks, sometimes there are different points of view when looking at data and trying to understand it. Are there any criteria to help us understand it in a better way? So I think, how do you resolve different points of view when looking at data?
I think this aspect of triangulation is going to be very, very important. We practice something called dialoguing. There's a big difference between discussions and dialogue. The word dialogue, many people misunderstand it, thinking that it's just a conversation between two people. That's not true. Dialogue is dia, which is via, and logos, which is truth. What's the path towards truth? So that's what it is. And a dialoguing perspective needs you to have needs you to be able to first thing you need to be able to do is suspend your assumptions, suspend your beliefs when you're getting into that conversation. The second perspective is have multiple perspectives and be able to put all of that and triangulate around that. And the third is have kind of the ability to moderate, so that whenever the dialogue is turning into a discussion of between me versus you and my point versus your point, you need to bring it back to this perspective. And that's very, very important in today's politics also. You're seeing that there is a polarization in our world where things are me versus you, but what about us is the question, because in the end of the day it's about us. And that perspective of bringing that coming together will need an approach to dialoguing.
Yeah, certainly having that conversation seems incredibly important. So yeah, you don't get anything resolved unless you talk about it with your colleagues. All right. So next question comes from Alex, saying, "Is the methodology available?" So this question came from when you were talking about the difference between the bottom up and the top down methodologies. So when you were sharing your screen.
Yeah, it's available, and it's you should be able to look at it. We are actually practicing it in more than 140 Fortune 500 customers. So if you're one of those customers, you will have access to it. If you're not one of those customers, you should, I think, you should go to our website and look it up. And we not only have a methodology but also have software, so which is an industrial kitchen. So our perspective was that we thought of it that the future is not a Superman model where you have the special guy who comes and does everything from Krypton, but it's not the robot also where everything is a machine. It's more the Iron Man model. So what we showed you was the Jarvis, the Iron Man suit, which anybody can enter and become an Iron Man.
That's cool. I would definitely like one of those Iron Man suits. All right. I don't think we have any more questions lined up. So from the audience. So I have one very final question before we finish. Is there anything exciting that you're working on at Mu Sigma that you want to tell us about?
There's so many different things. We are solving an issue of non-normal distributions for an insurance company, how macroeconomic factors affect store profitability, the cure of cancer for using for a pharma company. How technology companies can be thinking about product engineering better. So over 12 different industry verticals, we are solving problems in sales and marketing, in supply chain, in product risk, all of those kind of things. At any point of time, we would be solving about 1,500 to 2,000 problems for these 140 Fortune 500 clients. So we are a big nerd shop. uh,
That's fantastic. That's a lot of problems with data at any one time. All right, brilliant. Thank you so much for your time, Dhiraj. That was really informative stuff. Really great. Thanks. Thank you also to Reese for moderating. Thank you to everyone who asked a question. Thank you to everyone who showed up today. I hope to see you all again in future webinars. All right, goodbye.